The Air Force Research Laboratory's Cold Atom Lab is located at Kirtland Air Force Base in Albuquerque, New Mexico. We work with cold atoms as opposed to regular atoms because they are easier to control. Cold atoms are one technology that may help improve some of the world's most important technologies for accuracy and cost effectiveness. Hi, I'm Brian Cash. I'm a physicist at the Air Force Research Laboratory in Albuquerque, New Mexico. I work on cold atom inertial navigation, a technology to augment the global positioning system, otherwise known as GPS. Before we get into inertial navigation, let's talk about some of the problems with GPS. From a user perspective, there are a few big problems with GPS. One is it can be jammed. Jamming means that someone with some kind of device that often is just something they can hold in their hand can stop everyone in a certain area from picking up a GPS signal. Spoofing is another potential problem. What this means is that someone can pretend to be a GPS satellite that gives you a false position reading, and they can actually direct you to a place where you don't want to go. And finally, there's the possibility that one of our GPS satellites comes under direct attack and is taken out. One solution to these problems is cold atom inertial navigation. So this would be some kind of device, some kind of box that you could put on a vehicle or hold in your hand that would tell you just locally what your position is without having to communicate with a satellite. Obviously, something that is handheld like that is going to be more cost effective than a satellite, and you can make potentially thousands of these things for the cost of a single satellite. There are a number of labs around the world that are investigating cold atom inertial navigation, and the typical way this is done is you have this very cold cloud and you put it in a box, and you take everything else out of the box and you're just left with this cold cloud. And then you have a laser that is able to measure where this cold cloud is inside the box. Now, if the whole box moves because you're in a car and you start to drive, well, the atoms are going to get left behind. There's nothing causing them to move. So in the frame of this thing, which is now moving, it appears that the atoms are moving. And from that, you can figure out, well, what's really happening is my car is accelerating or my car is moving. So what we're doing in our lab is we're confining those atoms with a magnetic field, basically to prevent them from hitting the walls of this chamber that we've built around them. We take this cold cloud of atoms and we trap it in a magnetic field. And the device that we use to do that is called an atom chip. Basically, we run current through these wires that form this magnetic field of a particular shape just to hold the atoms exactly the way we want. That keeps them from crashing into the walls if our platform accelerates, for instance. Typically in other labs, making these atom chips involves lithography in a clean room. And it's a very time-consuming and costly process. It involves months of labor, tens of thousands of dollars, and what you get out at the end is an atom chip that can carry somewhere in the neighborhood of an amp, maybe 2 amps of electrical current. What that means is that the magnetic fields you can create are relatively small. What we do is we borrow a substrate from the power electronics industry. It's called direct bonded copper. And we laser etch the wires that we want to run current through onto that substrate. We have to very carefully laser etch these wires and remove material that might fall into the channel. That allows us to run something like tens or even 100 amps through these wires and make a much more significant magnetic field for trapping the atoms. So one of the biggest errors from the GPS system when you are a user is we don't actually know exactly where those satellites are. And so having a better position understanding of exactly where that satellite is can help improve the accuracy of the GPS system. In the civilian sector, aircraft are also relying on GPS. Then you have a number of other applications, for instance, farming or drilling. Some of these applications could benefit from having an inertial navigator in case GPS went down. The military relies on GPS for the guidance of munitions as well as aircraft and ships. Without GPS, you would lose a lot of that ability, and inertial navigation is something that could step in to augment your ability to know your position without GPS.